Hello all, back again with more fun with these extra problems. Today's statement reads, Magnetostatics treats the source current, the one that sets up the field, and the recipient current, the one that experiences the force, so asymmetrically that it is by no means obvious that the magnetic force between two current loops is consistent with Newton's third law. Show, starting with the Biot-Savart law, and the Lorentz force law, that the force on loop 2 to the loop 1 can be written as F2 equal negative mu naught 4 pi I1 I2, the double closed integral of script r hat divided by script r squared dl1 dl2. In this form, it is clear that F2 equal negative F1, since r hat changes direction with the roles of 1 and 2 are interchanged. All right, let's draw it up. We have some weird loop 1 with DL1 and some weird loop 2, DL2 with script R going from 1 to 2. Again, like they said in the problem, if we switch, then script R changes and we get the same thing. The two negatives cancel. All right, so starting from the Biot-Savart law, the field of loop 1 is B equal mu naught I1 over 4 pi, the closed integral dl1 cross r hat over r squared. Pretty familiar. We should be able to chug along with it. And then we know that the force per unit length is dl2 cross b, so we plug it in. And we see here that dl2 cross dl1 cross r is equal to the product rule here. When we plug all that in, now we can use some math to show that one of them cancels. The first term is what we want, and it remains that the second term needs to be shown to be equal to 0. So we know what script r is, by definition, x2 minus x1, and so forth. So the gradient of that from definition is equal to this mess of algebra, which we can simplify down into negative x squared minus x1 over r cubed x hat, and the same for y and z, which we can rewrite in terms of the vector r, which then, since we have a cubed in the bottom, we can shuffle one up and write script r as a unit vector, and thus we can go and apply the divergence theorem, well, not even divergence theorem, but set that equal to the divergence theorem, and then we can substitute in the gradient formula, and then show that that's equal to 0. So pretty cool. Just remember your math tricks.